All right, hello, Algebra 2. This is lesson 5.3, dividing radicals. And today is very important. This is a skill that is absolutely essential in higher math. And what we're going to be learning is how to multiply by the conjugate to clear radicals. And we use the conjugate a lot. Conjugate is just like in language, when you learn to conjugate a verb, you are changing a little piece of the root and it changes the meaning. So we have conjugates in math as well. So for instance, 2 minus 3 radical 5, I can change the conjugate simply by changing one sign. So it becomes 2 plus 3 radical 5. So that is the conjugate, where we just change one sign. If you have negative 2 minus 3 radical 5, again, I'm just going to change one sign, negative 2 plus 3 radical 5. And by changing one sign, you have done something mathematically significant, and it makes a huge difference. So these are conjugates, where we change one sign from negative to positive or vice versa. So you have M11 for practice, and we want to go ahead and just do a quick review here of dividing radicals. So when we have a giant radical, we can split it up into two smaller radicals. So this becomes the square root of 9 over the square root of 50, and we want to simplify those. So the square root of 9 is easy. That is a lovely perfect square, and the root is 3. 50 breaks apart into 25 times 2. And again, 25 is a lovely perfect square, and the square root of 25 is 5. So we get 5 radical 2. Now, we haven't done one like this, but again, we have a problem. We have a radical in the denominator, and we're not allowed to have that radical in the denominator, so we need to rationalize. And again, you should be writing this down. I'm writing it down. You should be too. So what's the problem here? To rationalize here, I want to get rid of this radical. So I'm going to go ahead and just multiply by radical 2 on top and bottom. The 5 is totally fine. So I really just need to get rid of the radical part. So that is nice. I'm going to go ahead and multiply straight across and see what happens here. Well, 3 times radical 2 is 3 radical 2. Here we have 5 times radical 2 times radical 2. Radical 2 times radical 2 is radical 4. Well, and that goes just a little bit further. We know that the square root of 4 is really 2, so that becomes 5 times 2, or 10. So we get 3 radical 2 over 10 for that simplification. Now, here's another thing. I do want to show you that you can do this stuff on your calculator. So I'm going to bring out my calculator here. I'm just in the regular math run menu. I can type in the square root. The square root button here is a second function right here above the x squared. So I'm going to do shift square root, and then in parentheses, I'm going to type in 9 divided by 50. And you can see I get a decimal of 0.424. So it is approximately 0.424. And if I do this, should it be the same or different? It should be the same. So it's really important you know that you can actually check your answers. So I'm going to go ahead and type in 3 radical 2. So 3 radical 2, and then divided by 10. And look, it also is 0.424. So keep that in mind. You should be able to check your answers. On this one, you may needed to make sure that you had that whole fraction in parentheses. So be careful when you're typing that in. The square root of 9 divided by 50 is in parentheses. This one, it wasn't necessary. All right. So make sure you can use your calculator. So we're going to do something differently. This, when we rationalized here, we just had to multiply by the radical. Really easy. This is a monomial, one term. And that's easy to do when you have a monomial. But we don't here. Here we have a binomial. Two terms, two things. So we have something else we need to do. So example 1 is simplify, rationalize the denominator. And again, they're telling us what to do, but it's a slightly different thing. Rationalize the denominator by multiplying by the conjugate. Okay, and this is really important because it's a binomial. If I were to multiply by radical 5 on top and bottom, I would have to distribute that to the 8. Well, now I've got a radical on the 8. All right, so just simply rationalizing with a radical 5 isn't enough. So what we're going to do is multiply by the conjugate. And remember, the conjugate changes one sign. So I'm going to multiply top and bottom by 8 plus radical 5. Again, I'm multiplying by 8 plus radical 5 over 8 plus radical 5, which is essentially 1. So I'm not changing the value of what I started with. All right, so now we have to multiply what we did in the previous lesson. So I'm going to go ahead and multiply this negative 3 inside here. Negative 3 times 8 is negative 24. Negative 3 times radical 5 is negative 3 radical 5. The denominator, I have to FOIL very, very, very carefully. So I'm going to go ahead and distribute this 8. So 8 times 8 is 64. And 8 times radical 5 is positive 8 radical 5. And then I'm going to distribute my negative radical 5. So negative radical 5 times 8 is negative 8 radical 5. And negative radical 5 times radical 5 is negative radical 25. All right, radical 5 times radical 5 is radical 25. All right, the numerator stays minus 3 radical 5. There we go. And what happens here in the denominator? So you'll notice when we multiply by the conjugate, this outside 8 radical 5 and inside the outer product and the inner product, positive 8 radical 5 and negative 8 radical 5 is 0. So that nicely goes away. And I'm left with 64 minus, what is the square root of 25? 5. So I get negative 24 minus 3 radical 5 over 64 minus 5 is 59. And it does not reduce. So this is a lovely answer. Refresher, things that divide by 3. This has a 3 in it. It obviously divides by 3. 24, 2 plus 4 is 6. And 6 divides by 3 evenly, so 24 divides by 3. Of course, you probably knew that. I wanted to check that here. 9 plus 5 is 14. 14 does not divide by 3 evenly, so 59 does not divide by 3. This is a great answer. All right, let's look down here. Letter B. So again, I'm going to multiply by the conjugate. And what is the conjugate of 9 plus radical 5? 9 minus radical 5. And I have to multiply top and bottom. So make sure that you This is mathematically correct. All right, we're going to go ahead and multiply by -8. So -8 times 9, 9 times 8 is 72, -72. And -8 times negative radical 5, negative times negative turns to positive 8 radical 5. In the denominator, 9 times 9 is 81. 9 times -5 is -9 radical 5. Distributing the net radical 5 times 9 is positive 9 radical 5. And radical 5 times negative radical 5 is negative radical 25. All right, my numerator, stays the same. I don't know why I wrote that. Negative 72 plus 8 radical 5. Again, in the denominator, this negative 9 radical 5 and positive 9 radical 5 makes a 0. Nice. And then we have 81. And we have a negative, what's the square root of 25? So 5, negative 5. And 81 minus 5 is 76. Oh boy. All right, this one does reduce. So here is really interesting. We have to reduce. And how do I know everything reduces? 72 and 8 and 76 are all even numbers, which means they're all divisible at least by 2. So what I'm going to do, the best way to reduce is say, what is this 76 dividing? 76 is dividing both terms upstairs. So I'm going to break that up. Negative 72 divided by 76 plus 8 radical 5 divided by 76. So that 76 divides both terms. So I like to say divide and conquer. All right, divide and conquer. Now we can reduce. I know that both of these divide by 2 on top and bottom. 72 divided by 2, I think it's 36. So negative 36. And 76 divided by 2 must be, I don't know, 78, I guess. That's one I don't come across very often. 76 divided by 2, 38. Oh, look, it divided some more. These are still both even numbers. So 2, they must have divided by 4, maybe? Okay, let's try 4. All right. So I'm just playing with numbers here. This is the one thing about IXL. It makes you think. 72 divided by 4 is 18. And 76 divided by 4 is 19. There we go. Okay, so 72 divided by 4 was 18. So negative 18. 76 divided by 4 is 19. And those I can't reduce anymore. Okay. And so that's a plus sign. Here, the 8 divides by 4 and the 76 divides by 4. So 8 divided by 4 is 2 radical 5. And again, 76 divided by 4 is 19. So this is a wonderful answer to put into IXL. It is also equivalent. They have the same denominator. So I could write negative 18 plus 2 radical 5 over 19 if I wanted to. I like this better, though. I think this is just fine. This is actually easier to type into your calculator also. All right, so lots of work there. These are equivalent, just in case you were curious. Common denominator. All right. A couple more. All right. This looks a little bit different, but it is still a binomial. We have 2 terms, so I'm going to multiply by the conjugate. And the conjugate just changes one sign. I don't have to change both signs. I'm just going to change one sign. And it doesn't matter which one, but negative radical 3 plus radical 2. Negative radical 3 plus radical 2. Top and bottom, we're multiplying. So I'm going to go ahead and then distribute the 4. So 4 times negative radical 3 is negative 4 radical 3. 4 times radical 2 is positive 4 radical 2. And in the denominator, Negative radical 3 times negative radical 3 is positive radical 9. Negative radical 3 times positive radical 2 is negative radical 6. Negative radical 2 times negative radical 3 is positive radical 6. And negative radical 2 times positive radical 2 is negative radical 4. You'll notice that the negative radical 6 and positive radical 6 make a 0. So now I can look at my numerator, leave that for radical 2. And then my denominator, radical 9 is a perfect square, that is 3. And radical 4 is a perfect square of 2. And so we get a 1 in the denominator. So negative 4 radical 3 plus 4 radical 2 over 1, which I don't need to write. Dividing by 1 is just the answer. So that's kind of nice. So that is 1. We don't really need a denominator of 1. That was nice. All right. Ooh, this one looks complicated. Okay. We're going to multiply by the conjugate. Again, picking one sign to change. So we are going to multiply by 3 minus 8 radical 5. And top and bottom. I'm going to distribute my numerator. So 10 radical 6 times 3. The 10 and the 6 are regular numbers that can be multiplied. So that becomes 30 radical 6. 10 radical 6 times negative 8 radical 5. Again, you can multiply the regular numbers together to get 80. And the radical numbers together and get 30. So radical 30. Lots of dividing by 10 here, I know. So we'll see if that reduces. All right, we're going to go ahead and distribute. 3 times 3 is 9. 3 times negative 8 radical 5. Again, you can multiply the regular numbers together. We get negative 24 radical 5. On the inside here, 8 radical 5 times 3. The regular numbers multiply. So we get positive 24 radical 5. And then last times last would be negative result. 8 times 8 is 8 times 8 is 64. And then radical 5 times radical 5 is radical 25. I'm curious if this radical 30 can be simplified. It's pretty large. But when I think about it, it is 6 times 5, and 6 is 2 times 3. So those are all prime, and we don't have any perfect squares. So it doesn't simplify. So 30 radical 6 minus 80 radical 30 over, what happens in the denominator? Negative 24 radical 5 and positive 24 radical 5 make a 0. But I definitely have some stuff to clean up here. Radical 25 is 5. So this becomes negative 64 times 5. Holy cannoli, another giant number I don't know the answer to. 64 times 5. Oh, there's the sweet spot. Negative 320. Good Jesus. All right, so 9 minus 320. That is just disgusting. 30 radical 6 minus 80 radical 30. And I'm 9 minus, I did divide, minus 320 is negative 311. Okay. I don't know what 311 is divisible by, but here's an interesting math tidbit here. If you take the square root of 311, it gives you 17. So all I need to do is actually take 311 and divide it by 2 and divide it by 3 and divide it by 4. divided, well, I know it's not divisible by 5, divided by 6, divided by 7, divided by 8, all the way up to 17. And if it's not divisible by any of those numbers lower than 17 and below, then it doesn't have any. It doesn't have any factors that reduce. So maybe 311 is prime. Divided by 9. But it's not divisible by 10. I already checked 11. 12. 13. Nope. 14. Nope. I don't think it's divisible by 15. 311 divided by 16 and 311 divided by 17. Nope. All right, so 311 is prime, so this is my final answer. All right, ladies and gentlemen, have a good time. Multiply by the conjugate.